So we're going to look at the reactivity of metals. First of all, we're going to look at oxidation and reduction. So in an oxidation reaction, a substance gains oxygen. In a reduction reaction, the substance loses oxygen. And oxidation and reduction always occur together. So as one thing gets oxidized, the other thing will get reduced. So some examples of this. In oxidation, when metals react with oxygen, they form metal oxides. So this example here is magnesium burning an oxygen, which gives off a very bright white flame. So magnesium plus oxygen goes to magnesium oxide. Because the oxygen reacts with the magnesium, the oxygen oxidizes the magnesium to form magnesium oxide. So oxidation is when you add oxygen to something. And here's the equation for that. Magnesium plus oxygen goes to magnesium oxide. And a balanced simple equation is 2Mg plus O2 goes to MgO. Okay, so now reduction. Metal oxides can be reduced by taking the oxygen away, because that's what reduction is. Reduction is removing oxygen. So as an example of this, when you heat lead oxide with carbon, the lead oxide becomes reduced, the oxygen is taken away to form just lead, and then the carbon reacts with the oxygen to form carbon dioxide. So it would be lead oxide goes to lead plus carbon dioxide. So because the lead loses its oxygen, so the lead oxide loses its oxygen to form lead. Because it loses its oxygen, it's reduced. And as we said, they always oxidation and reduction always happen at the same time. So although the lead oxide is reduced, the carbon gains oxygen, so the carbon is actually oxidized to form carbon dioxide. So the reaction for this, the equation for this is lead oxide goes to carbon, lead oxide plus carbon goes to lead plus carbon dioxide. The balanced simple equation for this is PbO2 plus C goes to Pb plus CO2. So you can see here, the lead oxide has lost its oxygen, the carbon has gained oxygen, so the lead oxide is reduced and the carbon is oxidized. So in summary, oxidation occurs when metals form metal oxides, and reduction is the loss of oxygen. Oxidation is the gain of oxygen. The oxidation of magnesium forms magnesium oxide, so magnesium plus oxygen goes to magnesium oxide, and the simple equation for that is 2Mg plus O2 goes to MgO. Lead oxide can be reduced by heating it with carbon, so the equation is lead oxide plus carbon goes to lead plus carbon dioxide, and the equation for that is PbO2 plus C goes to Pb plus CO2. So I would suggest looking at the this web link of the Thermite reaction and just making notes of that, because it is quite a good reaction to know of. So we're now going to look at the reactivity series of metals with water, mainly the alkali metals with water. Again, there's many videos that you can watch about the alkali metals. Okay, so this on the right is the reactivity series. So you get the more reactive ones at the top. So potassium is the most reactive one here. Then sodium, then calcium, then magnesium, then aluminium. Carbon is a non-metal, so it's only really there as a reference. It's not really part of the reactivity series. Then you've got the kind of middle reactive ones, zinc, iron, tin and lead. And then hydrogen again is for reference, and then you've got really low, the less reactive ones like copper, silver and gold at the bottom. Sometimes you might see platinum as well on the reactivity series. So You can test how reactive a metal is by either reacting it with acid or reacting them with water. Now, the alkali metals are far too reactive, so you would never react them with acids, but you can react the alkali metals with water, and they make some quite interesting reactions. So lithium fizzes around on the top, sodium a bit more vigorous, might have a little bit of a flame. Potassium is quite vigorous, and it actually spits out some flames as well. And then getting even more reactive, you can't really do them in a school, but there are some quite good videos of like francium exploding in a bath and things like that, which are quite good to watch. But it just shows how dangerous that they can get and how reactive they are. So that's why we don't do them in a classroom. So when you react an acid with a metal, you get a metal salt. But when you react a metal with water, you get, well, or an alkali metal with water, you get a metal hydroxide and hydrogen. So as an example of this, so lithium is the first alkali metal plus water goes to lithium hydroxide plus hydrogen. So when you react an alkali metal with water, you always get the metal hydroxide plus hydrogen. And remember, the way to test for hydrogen is the squeaky pop test. You put a lit spill into a test tube of hydrogen and it'll go out with a squeaky pop. So now if we look at the reactivity series of metals with acid, as I said, you wouldn't do the alkali metal ones with acid, but you can do the kind of mid-range reactive ones. So lithium, sodium, potassium will be too vigorous to react with acid, so it's not safe. But the ones like calcium, magnesium, zinc and iron are quite reactive with acids, and they're quite slow with water. Things like copper, gold won't even react with acids or water, so they're right at the bottom of the reactivity series. And as we said before, hydrogen and carbon are only really there for reference. They're not part of the reactivity series. So when you react a metal with acid, you form a salt plus hydrogen. So if you reacted hydrochloric acid with a metal, you'd get the metal chloride salt. If you reacted sulfuric acid, you'd get the metal sulfate salt. If you reacted nitric acid, you'd get metal nitrate salt. So as an example of an equation is magnesium plus hydrochloric acid goes to magnesium chloride plus hydrogen. Some other examples here, you've got magnesium plus sulfuric acid goes to magnesium sulfate plus hydrogen. Iron plus nitric acid would go to iron nitrate plus hydrogen. Calcium plus sulfuric acid would go to calcium sulfate plus hydrogen. Zinc plus hydrochloric acid would go with zinc chloride plus hydrogen. And that's it for the reactions of metals with acids and water.